Name. Please give me a thumbs up if I'm audible. Hello. I hope that I'm audible. So if you have any problem, you can post your questions or inquiries in the chat box. So we will start today's session. Okay. So first of all, I would like to revise what we have discussed in week 3 assignment. So for that, I request both of you that if you have any questions, then you can ask me. In the last lecture, we tried to solve one question where of cost theorem. So in cost theorem, we have mentioned that the first of all, property right is given to the victim, and then the transaction cost is zero. And we have to say that what is the level of pollution pre-negotiation and post-negotiation. So when there is no negotiation between the polluter and pollutee, the uh, property right is with the victim, so there will be no pollution at all. So in pre-negotiation case, the pollution level will be zero, and in post-negotiation case, the pollution level will be till x2. So that is what we have come to the conclusion for the first case when the property right is with the victim. So this is a typical question of cost theorem. And then now when there is negotiation, then what will be the benefit to the polluter? So this red part is the benefit to the polluter. Okay, and the polluter have to give some compensation for pollution to the victim, right? So this yellow part will be the compensation, and this blue part will be the cost of abatement which the victim have to incur to abate the emissions that is till the level of x2, which is done by polluter. So this cost of abatement will be incurred by the victim. So overall benefit to the positive benefit or benefit to the pollutee will be area y plus v. So this y plus v area will be the net positive benefit when the property right is given to the victim. So this is how we have mentioned. And for the polluter, um, Z and W area. So this blue part will be the benefit to the polluter. So this is what we have discussed. And the social surplus will be area Z, W, Y, and V. So this whole area, that is benefit to polluter plus benefit to pollutee, will be the net social welfare or net social gain. So initially, when there is zero pollution, there will be no production at all. However, in this case, the social welfare will also be zero. However, when we try to give some emit some level of pollution, then we will have positive social surplus. So that is what we have solved in this question. So no, when there is no negotiation, the pollution will be zero, and when there is negotiation, the pollution will be till x2. So that is what we have discussed. And in the second case, when the property right is given to the polluter instead of pollutee, instead of victim, then what is the level of pollution initially and post negotiation? So pre-negotiation, the polluter will pollute till its marginal benefit is zero. So till x max, the polluter will pollute. So when there is no negotiation, the level of pollution will be x max, and when there is negotiation, the level of pollution will be till x2. That is what we have discussed. And then in this case, the victim will give some bribe to the polluter. So this yellow area will be the benefit out of production, and this purple area will be benefit because of bribe which the victim give to the polluter. So extra benefit because of negotiation will be area S plus P. This area is extra benefit which the polluter is getting. And we have also discussed that what is the cost saving, right? So when there is pollution till x max, then the whole area, this whole triangle, let's say this whole triangle which I am drawing, will be the cost which the victim have to incur. However, when there is negotiation, this area R plus Q will be the cost saving, because they don't have to give this part of cost to any person. So this is the cost saving in the case when the property right is given to the polluter and there is negotiation. So when there is no negotiation, x max will be the level of pollution, and when there is negotiation, x2 will be the level of pollution. So if you have any question in this, then you can post in the chat box, or you can unmute yourself and ask me. Hello. So I will continue with the next part of the presentation. I hope that I'm audible and my screen is clearly visible. So we will move towards the next section. So this is the part 1 which we have discussed, and then we have solved some questions on cost theorem, where there is two plant, that is meat packing plant and then a spring water producer plant, and then by a cost theorem how they will negotiate. So this is the generalized cost theorem principle, where two parties, one will be polluter and one will be pollutee, that is the victim. So by their negotiation, optimum level of pollution is being achieved. So that is the cost theorem. After that, we have summarized the cost theorem, and then we have uh, uh, talked about the limitations of cost theorem. That the cost theorem assume that the transaction cost is zero. However, in real, the transaction, there is always a transaction cost. So we have said that cost theorem indirectly gives the importance of transaction cost, and the government have important role in assigning the property right as well as facilitating the negotiation. So that is what we have discussed. And then incentive design we have discussed, and we have solved some problems. So here the in an electricity market, we have given the demand curve, that is q is equals to 50 minus p, and then the marginal private cost curve, that is $10, and then the cost due to the smoke which is produced, that is social cost because of health damage, that is 15 per megawatt hour generated. So then the if there is no regulation, if there is no regulation on the pollution, then what will be the price and how much electricity will be produced, and when there is regulation, then what will be happen. So that we try to draw. So the demand curve will intersect at 50 comma 0 and 0 comma 50. So this is 0 comma 50 and 50 comma 0, since the uh, equation is q is equals to 50 minus p. And then the marginal cost, private marginal cost, will be this area, this line, that is $10. When we take the health damage, that is $15 per unit production. Then we get the marginal cost plus marginal damage, that is social marginal cost, which is equal to 25. So this is a straight line. So from here we have drawn in both the cases, like in case when there is no regulation, then the quantity which is produced is q comp, right? So this q comp value will be 50 minus p, where p is 10, so we get the value 40. So this is the production, higher production, when there is no regulation on the environment. However, when we impose some regulation on the environment, then q2 will be equal to 50 minus 25, that is p will be 25, right? So then we get lesser q2, that is 25, in comparison to previous case where the q2 will be 40. So we have always said that there is overproduction and overconsumption when there is no consideration of externalities. So if this externality is being considered, then the quantity will reduce, the quantity of production will reduce. So that is what we have come across. And then we solve. Okay, is there any question in between? Please ask me. Any question or queries? Hello. Okay, if there is any question, please post in the chat box. Then after this, we have solved one of the question where in this case, okay, in this case, there is a furniture company, and they produce some chemical waste which is being deposited in the river. So the river is also a fishing site for locals. So uh, there are some technology which for which the cost function is given as C1 is equals to 20A square, right? Where A is the level of pollution abatement. So per unit pollution for a unit of pollution abatement, the cost will be 20A square. Then what will be the benefit? Sorry, when the abatement is done, then the benefit will be 10 per unit. So if we try to draw the price versus abatement, then the benefit curve will be 10, that is constant. So it will be parallel to the x-axis, and we get the private marginal cost, which is differentiation of this, that will be 40A, right? So this private marginal cost and social marginal cost will be 40A. So this equation will be 40A. Okay, so we get private marginal cost, and private marginal benefit will be 0, because the company is not benefited from the abatement of uh, pollution. Then we get social marginal cost, which is equals to private marginal cost, that is 40A. After this, we have drawn the social marginal benefit curve. So social marginal benefit will be 10 per unit, right? So this line will be social marginal benefit. And then indicate the deadweight loss if the city takes no action. So that we will discuss in the next part. So here we have written that private marginal benefit will be 0, social marginal benefit will be 10, and private marginal cost is equals to social marginal cost will be the differentiation of cost function, that is 40A. And now we have to now we have to indicate the deadweight loss if the city takes no action. Let's say that uh, let's say that there is no action at all. So then this whole area, like mm, so this whole area will be the benefit. However, from here, this area will be the cost for abatement, right? Pollution abatement. However, this area is the net positive gain, which will be loss, which in the case when the action is not taken by city. So this DWL area, this purple area, is the deadbed loss if the city takes no action for the abatement of pollution. So there is social marginal benefit out of pollution abatement. However, if the pollution abatement is not done, then the society as a whole is losing a big amount that is shown in this area. So these are all we have discussed. Now, then we have said that if the city institute a per unit tax on chemical emissions, then what is the value of tax? So we have uh, discussed that the tax value will always be equal to social marginal cost, which is equals to social marginal benefit. So here social marginal cost and social marginal benefit intersect at this area. So the tax imposed will be $10. So that is what we have discussed in the last question with this examples. Now, after this, we have given a new cost, that is 20a square minus a. Okay, so this new cost function is given. Then illustrate the problem graph. So we have to say in case 1 and in case 2, if the marginal cost function is, let's say here it is 20a square. However, here the cost is lesser, marginal cost is lesser. Then what will be the level of abatement? A2. So in previous case, level of abatement is 1 by 4, right? So this A we get by equating 40A equals to 10, because we are equating social marginal cost with social marginal benefit. So this point where I have written the arrow, so that will be the abatement area, right? So we are if we equate this two, then we get the level of abatement, which is equals to 1 by 4. So in this case, then when the cost function reduces, then the level of abatement is A2, that is 11 by 40. So then they have asked that is there any deadbed loss, right? So the answer is that there is no deadbed loss. The firm adjusts to the social optimum in response to tax. So that is what we have drawn out of this question. So now okay. So till now, if you have any question, please post in the chat box, and we will continue with the next part of the session. Okay, now, so today we will be discussing about the incentive design under uncertainty and effectiveness, right? So, okay, so here previously we have talked about the Pigovian tax. So, in Pigovian tax, we have said that if there is a cost function, then let's say that this is the private marginal benefit. So this is the private marginal benefit, and this is the marginal cost curve, private marginal cost curve. However, because of the some damage to the society, there is a increase marginal cost plus marginal damage. So this will be the social marginal cost, right? So uh, therefore, the optimum level of production will be according to the intersection of social marginal cost and private marginal benefit or social marginal benefit. So then the Pigovian tax is one of the effective mechanism. However, many a times the Pigovan tax fails. Why? Because the marginal abatement cost curve or marginal social benefit. So social abatement cost and benefit out of abatement. So when there is uncertainty in this, then the uh, tax system fails. So in this we will discuss about the same issues. Okay, so I hope that I'm audible. I'll continue with the. Okay, so then we discussed that the when there is uncertainty in the marginal abatement cost or marginal social cost, that will be T is equals to beta times D uh, differentiate with respect to Q. So in this case, then the Pigouin tax fails because the one of the issue with the given tax is that the social marginal cost to the society will be uh, based on based on pollution or emission. However, many a times the pollution travels from one place to another. Then the effect is not directly observed. So that is one of the problem where MSC is not being calculated. And next one is there is huge amount of transaction cost to decide the marginal social cost. After that, marginal abatement cost is only known by firms. However, many a times the firm do not share their cost of abatement with the regulators, right? Because they have to incur the cost and they are not ready. So in this case also the policy makers face issues. So now we will discuss that when the marginal cost or marginal benefit is not known, then how effective the emission tax is, right? So in this case what we are doing is the marginal cost is uncertain and we are assuming the marginal benefit as a flat curve. So we are saying that the expected marginal cost. So this is my EMC. The EMC will be the expected marginal cost, which is calculated by regulators or policymakers, by which we get the XM level, right? So this is the level of abatement. And the marginal benefit is flat curve. So in this case, let's say that a marginal cost is higher than expected marginal cost in this case, then the level of abatement will be XH, right? And in the second case, if marginal cost is lower than the expected marginal cost, then the level of abatement will be XL. So XH and XL are for the case where marginal cost is higher or lower than the actual value of higher and lower than the expected value which the regulator have done. However, in all the point B, A, and let's say point O, the uh, uh, marginal cost is equals to marginal benefit is equals to T. So in both the case, let's say that in the point O case, here let's say point O, and then in the point A case and in the point B case, the private optima and social optima converges. So we can say that the emission tax is fully effective when the marginal benefit curve is flat. So that is what we have come across. Why? Because we have discussed before also that the taxation system is effective only when private optima converges with the social optima, right? So that is why in this case we are saying that the uh, emission tax is fully effective, though marginal cost is uncertain. So even if you don't know the marginal cost, or the expected marginal cost is lower or higher than the actual marginal cost of abatement, there will be always the optimum level of abatement. So next one, let's say that when marginal cost is uncertain and the marginal benefit curve is downward sloping. So this red line will be our marginal benefit curve, and we have three cases. So this is my actual expected marginal cost, which is done by the regulator. However, the marginal cost is higher than expected. So the actual marginal cost which a firm is incurring is higher than the expected marginal cost. In this case, the XH will be the level of abatement. However, by taxation system, so the expected value by intersection of EMC and marginal benefit, we have come across XM, that will be the optimum level of abatement, and from there we are calculating the T, right, tax amount. So the level of abatement which a firm will done which a firm will do will be till XH, right, till XH. However, if the policymaker knows the actual MCH, if if they know the actual MCH, then the optimum level will be this one, X star H. So there is reduced emission control in the case when the marginal cost is higher than the expected marginal cost. So that is in the first case. So now in the second case, marginal cost is lower than the expected marginal cost. Okay. Now let's say that the firm will the tax system is this yellow line, and when the yellow line intersect with MCL, then we get the level of abatement XL. However, the optimum level of abatement economically will be XL star. So the XL minus XL star will be the additional emission control, which is inefficient. So in the case B, there is too less of pollution control because there is reduced emission control. And in case A, at point A, there is too much of pollution control. So when the MB curve is downward sloping, then emission tax is not fully effective because there is either higher or lower level of pollution control, which is the divergence between private optima and social optima. So I will stop here. If you have any question, then we will continue with the next part. Okay, then we have discussed about the Weismann theorem. So Weismann theorem stated that in the presence of uncertainty, the Pigovan tax depends on the slope of MB and MC of the pollution control. If we make the MB flatter, the amount of divergence goes down and the effectiveness of emission increases. So as we have seen here, let's say that in case 1, the MB is flat where the emission tax is fully effective, and in case 2, the MB is downward sloping and emission tax is not fully effective. However, if we make this MB curve flatter, then the divergence between XH and XH star, or the divergence between XL and XL star, will reduce. So flatter the MB curve, more efficient will be the emission tax system. So that is what we have concluded from the first two cases and Weismann theorem. So now we are taking the case 3 where we don't know the marginal benefit. So we know the marginal cost of abatement, marginal cost of pollution abatement. However, we don't know the marginal benefit. So my EMB will be the expected marginal cost, expected marginal benefit, and actual marginal benefit might be higher or lower. So let's say that the actual marginal benefit will be lower. Then optimum level of emission control might will be XL if we know this exact MBL. However, since expected marginal benefit is this yellow line, then the intersection between this marginal cost and marginal benefit gives us to the level of X star. So this X star and XL amount. So this gap will be additional emission control which is being imposed on the firm. Similarly, when marginal benefit is higher than actual expected marginal benefit, let's say that actual marginal benefit will be higher, however, the policymaker assumed or calculated it as a lesser one. Then in this case, we know X star. However, XH will be the optimum level of abatement. However, the firm will abate till X star only. So this XH minus X star will be the reduced emission control, which is also not efficient. So M's. So this is the two cases which we have drawn across. So uh, now we are moving on to the limitations of emission tax. So limitations. So here in emission taxation system, we are saying that the private optima and social optima optima converges, right? And we find the value of tax, that is T. So however, many a times we don't know the marginal cost or marginal benefit, out of which we have discussed that there is uncertainty, and we have also summarized that flatter the marginal benefit curve, uh, more effective will be the emission tax system. Now we are seeing another big disadvantage is that, let's say that the regulator knows the like total emissions. Let's say that we cannot emit more than certain amount of CO2 in the air. Then let's say a tolerable limit of CO2 is 50 kg, and 100 kg of CO2 is too much to tolerate for the society. Then in this case, the emission tax will not be applicable. So because in emission tax system, the firm choose to abate pollution according to the cost, according to the marginal cost and marginal benefit curve, and there is no uh, net emission limit. So when the emission limit is fixed, the emission tax system is not efficient. Now we are discussing that what the government should do with the tax revenue. So there are many there are one of the uh, idea is that the tax revenue can be used to abate the pollution or to clean the environment. So the next one is in actual the tax revenue should be used in other areas in which the society's reliance on tax revenue from some other source goes down. So let's say that um, when the tax revenue is imposed on the emission, then the income tax can be reduced. So then the when the income tax goes down, the incentive for labor supply increases, and when the labor supply increases, the production of goods and services increases, leading to the reduced price. So this is called revenue recycling effect, in which the uh, tax revenue will be used to reduce the income tax. However, by imposing the emission tax on the firm to reduce the pollution is coming down, but there is um, but there is passing on of cost to the consumer, right? So the the double dividend, if sorry by imposing emission tax, they will be reducing pollution, and there will be more production. So this will be the double dividend, where the pollution will be lesser and production will be more, because the price reduces, so there will be more production. However, the pollution will be lesser because of the pollution control system. So this will be known as double dividend. However, there is second effect, which is tax interaction. So let's say that the emission tax is imposed on a firm, then the cost of production increases, so price of goods and services increases. So the net impact on the emission tax is negative. So the tax interaction will have negative uh, tax interaction will have negative effect on the price of goods and services, and the revenue recycling effect will have positive impact. However, the net impact of emission tax is negative, since the tax interaction is higher than the this uh, revenue recycling effect. So therefore, double dividend appears to disappear when we consider both the revenue recycling, which have positive effect, and tax interaction, which have negative effect. So that is what we have discussed. Okay, now we will discuss about the theory of second best. So here the as we have discussed that um, the income tax will be reduced when we take certain tax from the firm, which have a positive effect because of increased labor supply. However, there is a tax interaction which have negative effect on the price of goods and services. Therefore, the net impact of emission tax is negative, right? So here, the theory of second best said that if we cannot correct the market failure in all the market, then it is better not to correct in any of them. So let's say that emission the net effect of revenue recycling and tax interaction is anyway negative. So uh, that is one of the example that the policy is not working. So therefore this theory is called theory of second best. So here we are saying that uh, all the markets are interdependent, so all the sectors are interdependent. Let's say that if we are imposing certain policy on one of the sector, and another sector is being affected because of this policy negatively, then it is of no use to correct the market failure. That is what the theory of second base proposed. So imposing any policy on one market will impact on all the others. Then we need to decide about the net impact before actually implementing a policy on particular sector, because all the sectors are interdependent. So doing something on one sector by partial equilibrium framework may not result in more general well-being. So we have to consider all the interactions, and then try to maximize the general well-being rather than obtaining the um, well-being of certain sector or certain market. So with with this we have come to the end of emission tax system. Then we are talking about the tradable pollution limit. So let's say that there is two firm A and firm B, with firm A having higher uh, uh, okay, firm A have higher marginal cost than firm B. So let's say that the emission limit for both the firm will be 40 kg of CO2, 40 kg of CO2. Then the firm B, then the firm A optimum level of abatement is 10 kg, and for firm B, the abatement will be 20 kg. After that, the let's say that if the out of 40 kg, the abatement which is being done is 10 kg, then the emission which the firm A is doing is 30 kg. However, permits which the firm A have, that is that standard level of emission which firm A can do is 25 kg of CO2, that is 25 permit. One permit is equals to 1 kg of CO2. So the firm have 25 permit only. However, the firm A is emitting the pollution of 30 kg. Okay, so the additional permit which firm A required is 5, so that total emission comes total emissions come under as 25 only, right? Because it is emitting more than number of permits which it has. Then let's say that for firm B, optimum level of abatement is 20 kg. Since the marginal cost of firm B is lesser, so the emission which firm B does is 40 kg. So the net emission after abatement will be 20 kg, and the firm B have permit of 25 kg of CO2, and the actual emission is 20 kg, so it have one extra 5 extra permit, sorry, it have 5 extra permit. So in this case what firm A will do is firm A will buy 5 permit from firm B. So firm B will sell 5 permit and firm A will buy the same. So this system is known as tradable pollution permit. So in this system the number of permit is determined. So for both the firms, the permit level is given, which is, let's say, 25, right? And the abatement is done according to the marginal cost of each of the firm. So since marginal cost is higher for firm B, the abatement is lesser, and since for firm A, for firm B, the marginal cost is lesser, the abatement is higher. So the additional permit can be traded between both the firms so that the optimum uh, level of abatement is being done. So this is the concept of tradable pollution permit. If you have any question, then you can ask me. Okay, now let's say that how the permit is being granted, right? So there are two ways in which the permit is being granted. So the permit is the limit to the emission. So each of the firm have are given 25 kg of CO2 limit. Beyond that, if you emit, then you have to either pay the tax or you have to get the permit from other firms. So that is how the tradable pollution permit works. So there are two ways of distributing permits. First one is grandfathering and second one is auctioning. So in grandfathering, the permits are equally distributed among the firms. And in auctioning, the permits are being auctioned between the firms. So for those firms which have higher marginal abatement cost curve or higher cost of abatement, this firm will need more permits, and those firm which have lower abatement cost, those firm will require lesser level of permits. So the auctioning is done based on MAC. Now, in this case, M is the optimum level, optimum price per unit of permit. So this is my M, and for certain level of MAC and marginal abatement cost and marginal benefit, we get the price of permit which is equals to MB and MC. That is the optimum level of pollution control, right? So from here we are saying that the at the point where private optima and social optima merges, that will be the uh, level that will be the price of permit. So this will be same as the emission tax system where T is equals to MB is equals to MC, right? So the permit system is fully effective when private optima converge with social optima. So Okay, now if you have any question with this, you can post in the chat box. So in the meanwhile, I'll move to the next part. So in previous case, we have discussed on the emission tax system, the case one where MB is flat, right? So in the emission tax system, when the MB is flat, we have observed that the private optima and social optima converges and the emission tax system is effective. Now we will see whether the tradable pollution permit is effective when the MB curve is flat. So we have drawn the marginal cost and marginal benefit, out of which we have got the level of M. So that will be our optimum price per unit of permit. So let's say that there is three cases. Yes, there is two cases, and EMC is my expected marginal cost, which the regulator or the policymaker assumed, right? So when the expected marginal cost and marginal benefit intersect, that value will be my M, right? And I get the XM level of pollution. So XM will be my abatement level. Then now let's say that MCH. So MCH will be a higher marginal cost. In this case, the XH star, we get the optimum level as XH star. However, because of the expected marginal cost, uh, uh, obtaining the XM level, we have to abate till XM. So there will be the efficient level will be XH star. However, XM will be obtained because of the lack of knowledge of uh, marginal cost curve. So then this gap between the XH star and XM will be the extra pollution abatement. So though there is less permit in the market, a firm is forced to abate more pollution. So that will be the case when marginal cost curve is actual marginal cost curve is higher than the expected marginal cost curve. So in the next case, when actual marginal cost curve is lower than the expected marginal cost curve, then at point A, we get the XL level of abatement. So that will be the optimum level of abatement. However, the XM will be based on the expected marginal cost. So the firm will only abate till XM level, and then the firm will require less permit than allotted. And since the firm is already given uh, already expected up to XM only, though the rest of pollution control, like the firm can do till XL star, however, firm will do till XM. So in this case, there will be a lesser level of abatement. So even though the firm have the capacity to abate up to XL, they will abate only up to XM. So that is the case when marginal cost curve is actual marginal cost curve is lower than the expected marginal cost curve. So this is the case when MB curve is flat. So we can clearly say that when the MB curve is flat, the tradable pollution permit is not efficient, because there is always a divergence between the pollution control, optimum level of pollution control, and expected pollution control, right? So uh, in let's say that since the permit is not flexible like the emission charge system, uh, so it has opposite which is happening in the previous case, that is the emission control case. So in the permit system, in the tradable permission control system, here the once the permission is allotted, then the if there is surplus or if there is deficit, the policy maker cannot do not have the flexibility to do the changes. So here the permit system is not effective when the marginal benefit is flat straight line. So that is what we have observed here, that there is a divergence between the expected marginal cost and the optimal level of marginal cost based on the intersection of marginal benefit and marginal cost. So therefore we can say that when MB curve is flat, the tradable pollution permit system is not effective. Now we are moving on to the second part where we know the MB. So MB is steep downwards and we are uncertain about the marginal cost. So the expected marginal cost curve is here. So we get XM level. However, uh, let's say that the actual marginal cost is higher, then we get XH star. And in the second case, let's say that MCL is lower, then we get X star, let's say. Yeah, or let's consider this X star as XL star. So, compared to flat one, we have lesser divergence when we have steeper marginal benefit. So, the tradable permit system works better when the marginal benefit is steep straight line. So, that is what we have concluded, because the divergence between this XM and XH star and XM and X star is lesser compared to flat marginal benefit curve. Now we are assuming that we have a flatter marginal benefit curve. In this case, again we are getting lesser divergence between XM and XH star compared to previous one. And here we are getting lesser divergence between XM and XH. Uh, Sorry, here we are in the case compared to case 2, we are assuming the flatter MB curve and the divergence increases, because steeper the MB curve, there will be lesser divergence. So here in case 1 the divergence is lesser, and in case 2 the divergence is lesser, and in case 3 the divergence increases between the optimum level of abatement and expected level of abatement. So here the divergence between XM and XH and XM and XL is higher compared to case 2, since we have assumed that MB curve is flatter compared to case 2. So the permit system works poorly when the marginal benefit curve becomes flatter. So both the emission tax system and permit system works in opposite. So when our MB curve is flat, then uh, the emission tax system is better, and when the MB curve is downward sloping and steep, then we can say that the tradable pollution permit system works better. In the case when MC is uncertain, so marginal cost is not known by the policymakers. So if you have any question till now, then you can ask me. Uh, okay, now we will summarize the previous part. So emission tax and permit system works on totally different direction. Emission tax is more effective for flatter MB curve. Conversely, permit system is more effective for steeper MB curve. So also we can also say that the permit system is not flexible like emission tax system. Okay. Permit once allocated or allotted cannot be taken back. So this is all uh, we have discussed till now. Uh, Now we will try to solve one of the question. So for this, I might need the little bit of interaction if you are able to solve this question. So if you know the answer, please uh, try to answer in the chat box. So in this question, we are given two power plants. So there is two power plants. Uh, let's say that MIT plant and Harvard plant. So there are two plants at different locations, and both the plants are coal-based power plant, and they produce smoke, which is the byproduct of electricity production. So the marginal cost for reducing the smoke. So pollution abatement cost. This is the cost uh, curve that Cm function of Xm, where Xm indicates the total number of units of smoke abated, right? So that will be equal to 5x square. And in for the second plant, that is Harvard plant, the plant is slightly less efficient compared to MIT plant. So the cost is higher. So 7x square h plus 10xh, where xh indicates the total number of units of smoke emitted by the Harvard plant, right? So we are given both the cost function for both the power plant 1 and 2, and we have to we are also given the total benefit of the smoke to the city, which will be 100 times xm plus xh. So we are given the cost of abatement, as well as we are given the benefit of abatement. So if we abate the pollution, then the benefit to the city or to the society will be 100 xm plus xh. So we have to calculate the social optimum level of abatement for each of the plant. So for plant M and for plant H, what will be the optimum level of abatement? So in question number 1, we have to find the optimum level of abatement. So before that, I would like to ask, what will be the equation for marginal abatement cost for MIT and marginal abatement cost for Harvard? So for that, you have to give the answer in the chat box if you understand the question. So are you there? Can any one of you answer these questions? Are you able to understand the question? Hello? Yes, am I audible? Uh, Hello. If you are not able to speak up, then you can maybe post in the chat box. But it will be more beneficial or better if you try to interact so that we can discuss it better. Hello. Okay, now, so I'll continue with the answering part also. So here, what we are given. So here we are given the cost equation for cost, right? Now we have to find marginal abatement cost, MAC. So this MAC for H, for M will be differentiation of 5x square M. So if we differentiate both the cost function, then we will get the marginal abatement cost for both the plant H and M. So if we get the marginal abatement cost curve, then we will also get the marginal benefit curve, right? The benefit is given. So now we have to find the marginal benefit. So when we find the marginal benefit, then we have to differentiate the benefit curve with respect to xm and xh, right? So we have to find the socially optimum level of abatement. So when we draw the MSE and MB curve, we are getting the we have to calculate the marginal cost for abatement, which will be 10xm and 14xh plus 10, and marginal benefit of abatement will be 100, right? So when we have to find the socially optimum level of abatement, we are equating SMC and SMB, social marginal cost and social marginal benefit. So from here we are getting XM is equals to 10, because we are equating 10 XM is equals to 100. So we get XM is equals to 10, and if we equate this equal to 100, then we are getting 90 by 40. Okay, so that is how we have obtained the uh, answer of these two questions. So the cost function for abatement is given, and the benefit function is given. From both the cost, like let's say that the cost first, second, and benefit, we are trying to differentiate the cost with respect to XM and XH, and we are equating social marginal cost and social marginal benefit, out of which we are getting the value of XM and XH in both the cases. So if you have any question in this slides, then you can ask me in the chat. So yes, so I'll conclude one more time. So there are two power plants in a city which is called Cambridge. So the power plant, one first power plant is at MIT and second is at Harvard. So the both the power plants are coal-based plant, and these two power plants have different marginal abatement cost, right? So the marginal abatement cost curve for M plant is 5x square XM, where XM is the total number of units of smoke abated, right? And for Harvard plant also, the cost function is given, and the benefit for overall society is given as 100 XM plus XH, right? So when we try to derive the marginal cost of abatement. So we are differentiating the cost function with respect to abatement level. So we get, if we differentiate 5x square, 5xm square, then with respect to xm, then we are getting 10xm. And to get the optimum level, socially optimum level of abatement, then we can say that we will equate this with respect to marginal benefit. So the benefit will be, the benefit is given as 100 xm plus xh, and marginal benefit will be, marginal benefit will be 100 only. So we are equating the marginal cost with respect to 100, as we are when we differentiate with this function with respect to xm, we get 100. And similarly, we differentiate 7x square plus 10x, and then we get 14x h plus 10. And if we equate this with 100, then we get 90 by 14. So these are socially optimum level of abatement. So this is the first part of the question. Now let's say that the Cambridge government considers imposing tax on the power production. So the question is, what should be the tax that needs to be imposed to reach the abatement amounts which you calculate in the part 1? So we have to find the tax, sorry, we have to find the amount of tax in this case. So uh, what will be the tax amount which is to be imposed, right? So the optimum tax would be the negative of marginal benefit, that is 100 per unit of non-abatement. So since the marginal benefit is given as 100, the tax which should be imposed will be equal to 100. So for each unit of non-abated by the firm needs to be imposed 100 rupees of sorry 100 $100 or 100 rupees per unit of non-abatement. So I hope that this is clear. If you have any question, then you can ask me. So if we try to draw the marginal abatement cost curve, then in the case 1, we will say that when there is zero abatement, then it is 0, and then this will be the slope will be about 10 then. And in the second case, then let's say that this will be for my uh, so this is my MAC curve, right? Marginal abatement cost for the case of M plant. Okay, so for M plant, I have derived the marginal cost curve, and marginal benefit is 100, right? This is my marginal benefit. So for the value of tax, we are saying that T is equals to MC is equals to MB. So the tax value will be equal to 100. So that is how we have got 100 per unit of tax for each level of emission. So this is the this is how you will calculate the value of tax. So here we are saying that in the case 1, we have first derived the optimum level of abatement, and then we are trying to derive the tax amount for each unit of emission which is not being abated. So for each non-abatement 100 per unit of tax should be levied. 100 is the dollar, like rupees or dollar. Now let's say that in the next part, suppose instead of taxation, the Cambridge government tries to regulate quantities. However, the city of Cambridge cannot write a law for each firm, so it simply declares the Cambridge plant must cut down smoke XC is equals to 1 unit each year. So we have to show that uh, this system is ineffective, right? So in this case, this can be known as standard. This can be known as uniform standard. Okay, because each of the plant is given the value of a uniform cut of XC is equals to 1. So each unit have to cut 1 unit of a bit like 1 unit of smoke emission, right? So we have to show that this law is ineffective compared to emission taxation or any other system, right? So okay, so I'll stop for 1 minute. Uh, Hello. So sorry for the disturbance. So now we are saying that there is a uniform level of smoke or uniform standard is given for each of the plant, where they are mandated to reduce the smoke production by 1 unit each year. So we have to show that it is not efficient, right? So the marginal cost of abatement for each of the plant is different. For MIT plant, if we have to abate 1 unit, then it will be 10, because the MSC for marginal abatement cost is 10 xm, where xm value will be 1, right? So for MIT plant, it will be 10. However, for H plant, uh, it will be 14 into 1 plus 10, because this plant is having higher marginal abatement cost. So for both the plant, the marginal abatement cost for abatement of 1 unit of emission is very different. So for first plant, it is 10 only, but for the second plant, for the abatement of same level of emission, the price is 24, right? So uh, so we can say that if MIT abate bit more and Harvard abate bit less, there would be more abatement with lesser cost. So we can say that if we impose some standard, then the system or the uniform standard system is ineffective, because the abatement cost is higher. uh, so if the emission taxation system is there, then the cost would be lesser. So therefore, so this is the case where uniform standard is imposed, and each of the plant have to incur different cost, right? So that's why we can say that the overall system is inefficient. So we have to show that this system where each of the plant is mandated to reduce certain quantity. So we are regulating the quantity. So this regulation of quantity is ineffective. So that is what we have shown here. So now we are going to the next question, where we are saying that suddenly an economist is voted as mayor of Cambridge. So in the first two questions, like in the first question, we are imposing the emission tax, and we are finding the optimum level of abatement for each of the plants above which the tax is being levied, right? So in the first part, we have emission taxation system, and in the second part we are trying to regulate the quantity, and we have proven that this uniform regulation system is ineffective, because maybe if MIT a bit higher and Cambridge a bit lower, then we would have come to the optimum minimum cost uh, and higher abatement, right? So for more abatement at less cost, the uniform standard system is not applicable. So that is what we have discussed in the third part of the question. Now in the fourth part of the question, what we are trying to say is that okay, is there any question? Anyone? Satyashri? Hello? Hello? Okay, I'll continue with the same. So here what we are saying is that now there is a emission system where now this is the tradable permit system. So the third case where tradable permit system is imposed, right? So competitively trade in permits, and one of the like then what we said that mayor, like in favor of MIT plant, they have granted 5 permits, and Harvard is granted 0 permit. Now what we have to show is that the how since the MIT have 5 permits, and Harvard do not have any permit, the Harvard is expected to abet 5 units, right? And MIT, since it owns all the permit, is not expected to abet at all. So we have to show that Harvard will surely, this H plant will surely want to buy some MIT permits. So we have to explain this. So the question is that even though the MIT plant have 5 permits and Harvard plants do not have any permit. So Harvard plant, rather than abatement of 5 unit, the plant will choose to buy permit from MIT plant. So why will that be happening? So uh, if you try to answer this question, it will be better. So now the case is tradable permit system, and uh, the one of the plant is granted some permits and it is having lesser marginal abatement cost, and Harvard plant have a higher marginal abatement cost, and it have to abate some level of pollution. So that is 5 unit, since the Harvard have 0 permits. Now the question is that rather than abatement, the Harvard plant will choose to buy permit from MIT plant. So we have to explain that why will this be happening, right? So the answer is that the marginal cost of abatement for Harvard when there is no abatement at all is zero. Sorry, when marginal cost when while the marginal cost of abatement for so what we have to do is that we are given the marginal abatement cost curve, right? So for MIT it is 10 xm and for Harvard it is 14 xh plus 10. So when there is no, like when xh is 0, so for that value the cost will be 10. However, when xm is 0, the cost will be 0. So here what we are trying to say is that the marginal abatement cost for Harvard when XH is equal to 0 is 10, while marginal cost of abatement uh, at MIT is 10 into 5 for abatement of 5 unit of emission is 50. So therefore it is lot cheaper to abate at so, it is lot cheaper to abate uh, it is lot cheaper to buy permit compared to abatement, right? So so what we are saying is that the Harvard plant will buy 5 unit of 5 unit of abatement from MIT plant. So XM will be our 5. Here it is written wrong. So what we are trying to say is that in this case, when Harvard plant is not abating at all also, the cost is 10 rupees. Okay. And when MIT plant is abating 5 unit, the cost is 50. And if Harvard plant have to abate a 5 unit, then it will be the equation for the Howard plant will be 14 into 5 plus 10. So this cost will be very high. So rather than abating by Howard plant, it will choose to buy from MIT plant. So that is the conclusion, right? So even though MIT plant have permit for emission, the MIT plant will abate 5 unit of additional 5 unit of emission, and this extra permit will be sold to the Harvard plant, and Harvard plant will not choose to abate since its cost of abatement is very higher compared to the MIT plant. So that is what we have discussed in the question here. So it is lot cheaper to abate at, it is written wrong, so I'll just erase. So the conclusion is that the abatement needs to be done by MIT rather than Harvard. So Harvard plant will incur higher cost if it have to abate the pollution. So that is what we have concluded from this part. So this is the question of a tradable permit. So the permit will be traded, and the abatement will be based on the marginal abatement cost. So when the marginal abatement cost is lower, the plant will choose to abate more and sell the permit which is extra with the plant. And when the marginal abatement cost is high, then the plant will choose to buy some permits from the other plant. So this is the conclusion which we are drawing from the two cases. So we have taken two farms, that is plant A and plant B, and the plant plant with lesser marginal abatement cost curve will choose to abate 5 unit of uh, 5 unit of pollution rather than other plants, plant H, which have higher marginal abatement cost curve. So with this, I will conclude today's session. If you have any question, then you may ask. Otherwise, we will end the session. So, is there any question or any part which you want to discuss? Then maybe we can discuss. Satyashree, are you there? Okay, so I will end the today's session. If you have any more question, then you can ask me. Here in this lecture, we have actually tried to solve some questions. So the previous question was on cost theorem, and so you'll get the slides also. So the cost theorem question we have tried to solve, and then we come to the next question where we are trying to solve the emission tax system, and we are finding the private marginal cost, social marginal cost, and then marginal benefits. From here we have solved the questions with different marginal cost also, and then we come to the incentive design in various uncertainty cases, and what is the effectiveness of different pollution control, including the uh, taxation system and tradable pollution permits. So we have concluded that in case of emission tax, the flatter the MB curve, more efficient will be the flatter the MB curve, more efficient will be the system. So the when the MC is uncertain and MB marginal benefit is flat, then emission tax system is fully effective. However, when MB curve is downward sloping, then emission tax system is not fully effective. So in emission taxation system, flatter the MB curve, more benefit you will get out of it. And then in the next part, we have jumped to the tradable pollution permit after discussing about the limitations of PQ1 taxation as well as limitations of emission tax system. So we have said that let's say that we have a certain fixed amount of emission, then emission taxation system is inefficient. Then in tradable pollution permit system, the regulator gives permits to each of the firm, and the abatement is done based on the marginal abatement cost curve. And if a plant is if the plant is abating more, and it have extra permit, then it can sell the permit, and those plant which are not able to abate pollution because of higher marginal cost, those plant can buy permits from other plants. So it will be like abatement based on the marginal abatement cost curve. So either the plant will choose to buy permits, or it will try to abate the emission. So based on it, we have discussed three cases, that is flat marginal benefit curve, and then steep marginal benefit curve. So in contrast to the emission taxation system, in this case, the flat marginal benefit curve, uh, the tradable pollution permit system is inefficient, and steeper the marginal benefit curve, more efficient is the tradable pollution permit system. So after that, we have tried to solve one of the question with three different kind of approach. First level is on the emission taxation system. Second level is on the standards, like the regulation is being done on the level of pollution. So the quantity regulation is being done. So we have proved that the quantity regulation is inefficient, because even though the price is higher for higher marginal abatement cost curve, this plant have to abate the emission, and the total cost incurred by the society is high. So rather than the uniform standard system, maybe we have to go to either tradable permit system or to the emission taxation system. So in the question 4 part, we have tried to look into the case where the one of the plant is given 5 permit, and another plant with higher marginal abatement cost curve is given 0 permit. However, it is expected to abate the pollution, which is equal to 5 unit. So the question is whether this plant will abate 5 unit of pollution, or it will buy permit from MIT. So since the marginal abatement cost of MIT plant is lower than Harvard plant, so the plant will buy permit, the Harvard plant will buy 5 permit from MIT plant, and MIT plant will abate 5 units of pollution, though it have 5 permits initially. So this is how the tradable permit system works. So with this, we will conclude today's session. So if you have any question, you can post in the chat box of the NPTEL forum, or you will get the video recordings also. So that is all. Thank you.